Welcome everyone. Today I'm going to discuss about digital twin, which is very important for VR and AR. A digital twin is an integrated multi-physical, multi-scale probabilistics simulations or a complex products and uses the best available physical models, sensor object, etc. to mirror the life of its corresponding twin. Once the vehicle is launched, the digital twin will increase the reliability of the flying vehicles because of its ability to continuously monitor and mitigate degradations and anomalies event. Digital twin, evolutionary steps, self-learning and adaptive system, anomaly detections, automatics, fault prediction systems, qualitative and functional model. Failure behaviors model as functions of operating conditions where both analysis, fault trace, predictive tests, life cycle data, operation logbooks, repair database, engineering documentation. Digital twin, two approach, knowledge-based approach, failure mechanism understood, small set of data required of the extra model mostly interpretables and transferable, mechanism need to be understood, limited failure mechanism understanding, large set of data required to extra model of neither interpretables nor transferable, model cheap to learn. Beside that, digital reliability twin. Our experience in electronics, failure is operating usually rare, complex immigrant phenomena. Complex failure mechanism, little to no data, little to no model. CIBD failure model regulations. Failures model analysis root cause. The reason of the fault is the degradations of the C8 electro lytic capacitors of 10 UF 335 volt. The capacitors 3D found dead in a general purpose grade electronic capacity 10 UF 35V. Two brand has been identified for the three PCTUMs and Yellowstones. The capacitor is used to power the PMW. Digital reliability twin. Our experience in electronic failure is operations usually rare complex emergent phenomena, complex failure mechanism, little to no data, little to no models. Possible to predict, prevent, mitigate such behavior mostly by learning from failures and generating to the new operating condition to do so require data inefficient flexible framework. Reliability model uses 1 to 580 system operation conditions, uses 2 to 19 system operating condition, uses 3 to 116 SYS testing conditions. Future uses 20 such operating conditions. Uses cause AC/DC power converter learned from existing system. Operations under three different conditions, 59 failure, three failures model, optimize operations of the new system, two conditions, 3A and 16 lifetime 100 days, and what is optimum maintenance strategy in terms of LCC. Simulation result, main result maintains with the lowest LCC highly dependent on operation conditions. Possible to identify since digital reliability twin explicitity model depends on operation conditions. Criticism. Generated digital twin after accumulating knowledge over 10 years of operation, but should be possible within first year or even earlier, but not sufficient accumulated knowledge, reliability testing, reuse knowledge from older systems. So digital twin paradigm can be valuable in practice if compatible within a limited data knowledge scenario, should allow to integrated all available knowledge and data from past and current system, should be able to function across different operating conditions, should allow to uncertainty propagations for teaching details of the presenting methods. Reliability model. Operating conditions. Operating condition is the failure stress to acceleration, accelerations to failures. Simulations. Start simulations. Uh, it depends on if T is 2, then terminate simulations. If T is greater than TP, then repair preventive, draw new lifetimes from model 1 for all failure model affected by the repair. If critical failure repair finance, then log downtime spent in critical repairs. Draw new lifetime from model 1 for all failure model accepted by repair. Simulations. Simulate failure behavior and operations. Track failures and replacement over lifetime to calculate life cycle cost. Core model, core initializers, QI initializer, dependency initializer, use case data analysis, load proportional power law accelerations empirically determine weak wear out behaviors, unknown load or proportional power law accelerator empirically determine no wear out behavior, capacity degradations, mechanism, transit voltage suppress headed electrolyte capacitors lead to evaporations. Operation condition failure stress empirically determined failure stress acceleration well studied in literature strong well out behavior. Use case discussion. Why such different behavior? FM1, FM2 are constant in time. FM3 has a strong wear out behavior. For low current FM3 in active system shows no wear out behavior. Preventive maintenance are useless for high current FM3 active. System show wear out behavior. Prevention maintenance usefulness. Methodology overview. Data collection, digital twin synthesis, simulation behavior, and digital decision making. The proportion of time in unit U is a functional state availability E uptimes E U uptimes plus E downtimes. Methodology qualify failure mechanism, maintain stress, TTF or well-beings, and methodology quantify failure mechanisms. So this is the way we can discuss more about digital twin and digital twin can helpful for AR and VR. So I just want to uh, refer the IBM sites. What does digital twin? A digital twin is a virtual representation of an objective or system that span life cycle is update from real-time data and uses simulation mechanism learning reasonable to help decision making. How does digital twin work? A digital twin is a virtual model designed to accelerate reflect a physical object. The object being studied, for example, a wind turbine, is outfitted with the various sensor related to virtual area of functionality. The sensor produce data about different aspects of the physical object performance, such as energy output, temperature, weather conditions, and more. This data is the related to a processing system and applied to the digital copy. Once informed with the such data, the virtual model can be used to run simulation, study performance issues, and generate possible improvement, all with the goal of generating valuable insight which can be applied back to the original physical objective. Digital twin versus simulations. Although simulations and digital twin both utilize digital model to replicate a system, various process, a digital twin is actually a virtual environment which make it considerably rich for study. The difference between digital twin and simulations is largely a matter of scale. While a simulations typically studies one particular process, a digital twin can instead run any number of useful simulations in order to study multiple processes. This is the way we can learn, we can understand digital twin, and we can take necessary initiative. Thank you everyone. If you have any question, you directly can communicate with me. Thank you. Bye bye and take care.